In this video, we're going to look at finding equations of parabolas with given information. So we are going to continue using those two forms, the two standard forms of a parabola to do this. So just to recall what they are, writing them off to the side here, we have x minus h squared equals 4p y minus k, and y minus k squared equals 4p equals x minus h. So with these two forms, we can find the equation of a parabola given enough information. Typically, we need two or more pieces of information, depending on exactly what we're given. So I've got a few problems written up here. Let's just work our way through them. First, find the equation of a parabola with a vertex of 3, 2, and a focus of -1, 2. As I've said about 1,000 times already in this class, I'm going to start with a sketch. Really will make your life so much easier to kind of sketch what's going on, think about it that way, and then from there make a choice of which form do I need to use, what do I have, what do I need to find. So the vertex was 1, 2, 3, 1, 2, and the focus -1, 2. So let me label these two. That's always a good idea. My vertex was the first point, focus was the second point. And again, my drawings are ugly, but I'm just using this to get a sketch. I don't really care what the drawing looks like beyond that I now know which direction it opens. It's opening to the left. And so I don't know that I have the width on this thing right. I have no idea how wide or shallow it is, but I know that that graph is opening the correct way. So if it's opening the correct way, that tells me I need to be using the y minus k squared equals 4p x minus h. I also know that that p is going to be negative. We can find its value in just a minute, but I know that p is going to be negative. I wrote these equations down a second ago just to help us recall what they were. I do think it's a good idea. Always start by writing down the form of the equation that you want to use. It's going to be especially true as we get further into the conic sections where we have parabolas, we already know circles, we have ellipses, we're going to have hyperbolas. As we have all these different forms, it's very helpful to write down that just general standard form, or the standard form, the standard form first so we know what we're trying to get to. Already I know that I have my h and k. I was told that my vertex 3, 2 I can put the 3 in for the h, the 2 in for the y. And that means I really just need to find this p right here. That's the only thing I have to find. And so recall, what is the p? Well, p gives the distance from the vertex to the focus. So I can see they're lining up on the x, on an x-axis. The heights are the same, the 2's are the same. So I want to figure out how much distance is between them. So I'm going to take the -1 and I'm going to subtract the 3. And that's a -4. Now, how did I know to go in that order? Here's the thing, it really doesn't matter. We said we knew the p had to be the negative, so if you did in the opposite order, if you took the 3 and subtracted the -1, you're still going to get 4. It's just you're going to have to remember, hey, it needs to be a negative, it's opening to the left. But formally what we're doing is we're starting with the focus, and then we're subtracting off the vertex. So with this, I'm done. I have y minus 2 squared is equal to, well, 4 times a -4 is going to be a -16, x minus 3. And that's all there is to it. Let's take a look at another example. Find the equation of a parabola with a vertex of -1, 2 that has an axis of symmetry parallel to the x-axis and an x-intercept of 5. Once again, I'm going to start with a sketch. -1, -2. That is my vertex. Notice here we're given 3 pieces of information because just 2 wouldn't have been enough. If I had known the axis symmetry was parallel to the x-axis, axis symmetry, remember, is that thing that kind of cuts the shape in half. We know that parabolas have symmetry. So I wouldn't know with just this any other points. I'd have one point I know if it's either left or right or up and left or right. I would know it's not up and down. Also, with just the x-intercept, those were the only 2 points I had. There's nothing stopping me from saying, well, it opens like this. And so now that I know all these pieces of information all together, I know that it has to open again to the left. So we're going to have another form, y minus k squared is equal to 4p x minus h. Well, my k was a -2, so that's going to turn to y plus 2 squared is equal to 4p x minus a -1 turns into a +1. Now before it was fairly easy to get that p because we just figured out how far it was between the 2 points. But here, this x-intercept is absolutely meaningless in terms of p. It doesn't even have to be that x-intercept is sitting on the line that the focus would be at, right? That the fact that there is was that 4 units of distance. I did this completely wrong too. X-intercept's +5, not a -5, so it should have been over here. Still opening left and right, but we know the p is going to be a positive. It should be sitting 6 units away from the vertex. That distance there is 6, but again, that's meaningless. That's not my p. X-intercept is just a random point along this curve. So what that does give me, though, is a xy coordinate. The x-intercept is the point 5, 0. So anytime I have an equation with a single unknown, in this case the p is an unknown, I can always take an x and y value, a known point, plug it in, and use that to solve for that unknown. So our y was 0. Our x was 5. So we'd have 4 is equal to 4p times 6. I could divide by the 4 and the 6. Here's the thing, I really want to know what the 4p is. I want to know the coefficient on that thing. If I want to know the p, I would divide by the 4 and the 6 and I'd get a sixth. P is equal to 1/6. But I could also just solve for the 4p. 4p would be equal to 4 over 6, or 2/3. And again, the reason for that is that's what I need to plug into the equation. So 4p would be 2/3 x plus 1. And that would be our equation. Let's take one last example. Find the equation of a parabola that has a focus of -2,7 and a directrix of -5. -2, 1, 2, 3, 4, 5, 6, 7. And then a directrix at x equals -5. And so we know that the parabola has to contain its focus and also point away from its directrix. So it's going to have to open to the right. If it opened up or down, it would have crossed over that directrix. If it opened up, down, or left, it would have crossed over the directrix, so it has to open to the right. And so, once again, we have the form y minus k squared is equal to 4p x minus h. Now, I've done 3 cases where it's opening left and right. I chose to do that just because I think we're a little bit less comfortable with those because they are not functions. It also makes it a little bit more challenging to use things like the quadratic form. We can't get around the standard form of a parabola because they are not quadratic. So, again, we should be comfortable with all the orientations, but I'm really practicing these left and rights because they're a little bit more new to us, but definitely encourage you to practice them up and downs on your own. Here we have the focus and the directrix. We do not have the vertex. We don't know the h and k right away, and we also don't know the p right away. So remember though that focus and directrix evenly split the vertex. The vertex has to be exactly in the middle. So if I think, okay, the focus was at -2, the directrix was at -5, I'll figure out the halfway point between them, and I can do that with a midpoint, simple midpoint, or you could figure out the difference between them and take half of that. But halfway between -2 and -5 is -7 halves, or -3 1/2. So what that tells me is the vertex has to be at the point -7 halves, comma, 7. Has to share one of its coordinates with the focus. It's going to be at the same height. It's just splitting the difference between these two elements. So we can go ahead and start inserting this. Y minus 7 squared equals 4p, which we're going to figure out in just a second, x plus the 7 halves. And I do need to figure out that p, so remember the p is the distance between the vertex and the directrix, or the vertex and the focus. So we found this to be at 3 1/2, or 7 halves, and so that's 1.5 units, or 3 halves units difference between the vertex and the focus, or the vertex and the directrix. Another way to think about it, there are 3 total units between the focus and the directrix, from -2 to 5. -5 was 3 units. Half of that would be 3 halves. So we'll have the 4 times the 3 halves. Squeeze that in there. So we'll have a y minus 7 squared is equal to half of 4 is 2 times 3 is 6, x plus 7 halves. There are many pieces of information we could be given to find the equation of a parabola. We should be comfortable again working with all those different pieces of information to get equations. So these were 3 examples, but again, continue to practice on your own. Think about the different ways it could be presented and how we can get to our equations.